Well, we could get started with the introductions part since as people are coming in. I'm June Mark. I'm from Education Development Center. I'm here today with my colleagues Paul Goldenberg, Kate Coleman, Zach Kolar, Deborah Spencer, Kristen Reed. I think that's the team that's here today. We're going to be talking with you today about an NSF-funded project that we've been involved in that's really exploring the idea of integrating programming as a language to help students explore and express their mathematical ideas. We've been working on this for the last few years, and we've been developing and testing these ideas, and we're excited to be able to share them with you today. I see that in the audience we have some familiar faces and also some new faces, and we've done a session each year at SnapCon, but I want to let the people who have been to a Math+C session here before that we have some new things to share with you. And if you're new to this work, there's going to be plenty of context and information we'll share about the breadth of the work. So that will be hopefully, open for you to be engaging with that as well. So we welcome everyone here. Next slide. We're going to just start with some introductions. We'd like to get to know kind of who you are, what brings you here, and hopefully make connections amongst yourselves as well. So if you could take a moment to put in the chat your name, where you're from, location or organization or both, and what brings you to this session, that would be great, and we'll kind of get started in a bit. It looks like we have people from all over, close by, further away, in the US, out of the US. Very nice to see such a range of people here. Well, thank you and welcome. And Dave, we do know Mary Fries. Many of us work very closely with her. Well, thank you. Next slide. I have mentioned the names. Here's the team, our Math+C team, and many of us are here today. We are really fortunate to have a sort of wide range of experience and expertise on the project, including math and computer science educators, curriculum developers, education researchers. The SNAP developers are represented on our team, and as well elementary teachers and coaches. Next slide. It's been a real pleasure in this project to work closely with a public elementary school here in Massachusetts. And it's called the Plympton School. It's in Waltham, Massachusetts, and in the Waltham Public Schools District. We have been really fortunate to work with the math coach, Zach Kolar, who's here today, is also, as well as being on the EDC team, is a digital literacy teacher at the Plympton School. The principal has been involved, and teachers in grades 2 to 5. And one aspect that's been especially nice for us has been that when we first started testing in classrooms, we worked with second graders kind of pre-pandemic in their classrooms, and now those second graders are going to be rising 5th graders, and they've worked with us both in their classroom, online, through Google Meet, and just have it's been especially nice to really see the development of their thinking, their comfort with programming in Snap, and how that has evolved over the years. So that's been a really nice aspect of this partnership with the Plympton School. Next slide.
We've had a chance to work both with new kids at older grades and with this continuing
Yes.
group. And
Yes.
it's been really spectacular.
Yeah. We're going to be sharing with you a number of micro worlds that we have developed. I think those of you who might have been here before have seen like our initial development where we had 2 or 3 micro worlds, and then we've been adding to that each year, and it covers content that's across the grades 2 to 5. And I think these are 9 micro worlds that have all been developed and tested. And so we're going to show you a little bit of those, and we're going to actually dig in a little bit more to the angles and shapes micro world later in this session. We're also going to give you like a sneak peek of one that's under development. And we know that many of you in this community are interested in sort of customizing, adapting, building your own micro worlds. So later in the session, we're also going to be talking a little bit about some of the tools and resources we've developed for doing that. Next slide. So we're going to first give you a very brief introduction to like kind of the breadth of these micro worlds, and give you a sense of what they look like and a very brief description of what they focus on. So one of the first that we developed was this number line environment. It's really focused on addition and subtraction on the number line. It is a sort of kind of a model for these micro worlds, in that I think there's a few things I just wanted to point out. There are, within SNAP, what we've done is limit the number of blocks that students have access to here, so that it sort of focuses the exploration. So there's just the plus and minus 5 and plus and minus 3 blocks in this environment. There's a startup block, and then you'll see below that explorations, and below the stage set 1, 2, and 3. So what we have designed is a set of kind of carefully crafted puzzles that present challenges to the students. Like you see, try to label all the numbers from 0 to 10 in this GIF that you're watching. So what the environment has done is try to create a sort of focused environment for students to explore the mathematics. And then the stage is customized. In this case, it has the number line. In some cases, it might have a coordinate grid or an array, something like that, that focuses on the mathematics that the students are driving through their scripts. They're creating kind of fairly simple scripts, but programs, authentic programs, and they get to see how those programs behave on the stage. So they have that. So those are some of the, the blocks might change, the stage might change, but that's some of how the micro world environments are structured.
Could I add just a little thing? What makes a puzzle different from a standard book example is that the results are really not obvious. So making 8 out of +3 and +5 is a standard, and that would be a standard thing. Making 2 or making all the numbers, that's different. So the kids get a lot of practice, and although any bit of this arithmetic is simple for many of them, obviously they get enough practice so that if it isn't simple, they learn something. But they're also doing a lot of thinking.
Yeah, and the 5 and 3 were really specifically chosen so that it's like not totally easy to make 1, which would make it easy to make all the other numbers. So that that design element is the puzzles. We spend a lot of time working on the puzzles. Okay, next slide. So there are this number line environment also has a couple of variations that we've developed. One that's focused on fractions, and then the next one I'll talk briefly about is decimals. Oops, I'm sorry, Zach, I'm still on the fraction one, sorry. In this environment, students get to explore eighths and halves. They work with adding and subtracting fractions, and the blocks are different, but they see that the behavior and how these numbers operate is still similar to the number line environment and the sort of structure of the number system. We also, I just want to note a couple of additional blocks that are being offered. There's a repeat block, and so our kids love the opportunity to use repeat, but that is, we're introducing other programming and elements that allow them to develop their both programming experience, but engage the thinking that they want in terms of solving the puzzles.
And the mathematics becomes multiplication.
Yes. So, and then Zach, now the decimals is good. So here, where we know we've extended these same ideas to the decimal world as well, and with different challenges.
The combined steps block, by the way, is one that kids asked for in second grade before we even started in this current school. It basically is an abstraction that says, show me that result without all the jumps.
Thanks, Paul. I'm going to turn it over to Kate, who's going to share about some of our other microworlds.
Thanks, June. So you've obviously had an introduction to our number line microworlds, but we have some others as well. And this one is called place value, ones, tens, 100s. And you can see here that we have the ones, tens, 100s blocks, both for addition and subtraction, and that this microworld's focusing on building children's understanding of place value as they build various numbers. These might be 2-digit numbers, they might be 3-digit numbers. And then in later puzzles, their students are introduced to repeat, which June, you mentioned already, to build even larger numbers. Next slide, please. This is our town map microworld. This is sort of for our young elementary students, sort of a gentle first taste of coordinates, where students are visiting a particular friend or name on the microworld, and then they're moving to visit another friend. They're walking sort of across the various parts of the grid, and that they really don't understand at this point, which you'll see later. We have a coordinates world, which is on our next slide. They haven't had this like formal introduction to coordinates, but this world's really building that background understanding for them. And I think a nice customization that's a huge highlight for students is that they can customize the names on the map and design their town to be whatever they want it to be. So we've had pizza shops, movie theaters, Paul's house, various names on the map. Next slide, please. And so from our town map microworld, this goes into sort of our upper elementary grades, where students are now using mathematical convention to show and express their understanding. And in this world, whereas in contrast to our town map world, where students were just walking along the coordinate plane, there's 3 different types of movement here. There is the walking by being able to walk north, south, east, and west. They also can fly to various points and fly in a direction. Students also have the chance to build additional buildings, points on the coordinate plane, and remove buildings. So, and even in later puzzles, just to mention, students have a chance to actually play with a block that reports the distance between 2 points. Next slide, please. And then in our arrays world is really focused for perhaps younger elementary students who are just exploring these ideas of pre-multiplication. So students here are considering the number of squares in each row and the numbers of rows to create these various arrays. They're introduced to initial ideas of area, lots of use of repeat, and students have to really learn how to create sort of this rectangle generator of how to create this array and what order of the blocks need to be in order to make that actually happen on the stage. And I think another key highlight here is just students love customizing the colors, lots of color choice. Next
I was
slide.
going to add that I didn't.
Yeah, that's a huge, I mean, my own children both love this world for that reason. So, because I have elementary age students that live in my house. On our next slide, this is the multiplication world. So this notion that as students' mathematical ideas grow, the language that they need to express those ideas must grow with them as well. And so here in our multiplication microworld, we're offering new programming ideas. This world's focused on functional programming, and children here are creating mathematical expressions. They're being able to put them in a list. They're able to sort that list. They're able to sort of prune that list, to make changes, to remove expressions. And they're really having a chance to explore the notion of prime numbers, or what eventually might be a prime number and what isn't a prime. So there's a lot of exploration in this world. That's been a lot of fun.
Kate, can I add that this world also has this option for the kids to see their lists in this list form or in a hundreds chart?
Right, in a hundreds chart, yes.
Really,
which you're not seeing on the GIF right now, right? Yeah, absolutely, Deb. Thank you for sharing that. And lastly, in our angles and shapes microworld, students, this is one of our newest microworlds. I'm really not going to say much because Paul's going to give you a deeper introduction into this momentarily. But students are learning ways to create shapes and designs using angle measures, and use customizations like color to do so. And I'm going to turn it back to June.
Okay. So that gives you a sense of the breadth of some of the microworlds, a little bit about sort of what we are trying to do and what we're studying as part of the microworlds. You know, this idea that programming can be a language that supports students' mathematical and computational thinking is something that we are investigating, and that, you know, part of what we're focusing on is in that in the slide, the phrase suitably designed, I think is a piece that we're really focusing on in terms of all of the kinds of design elements and features in this environment that make them kind of engaging to students, accessible to students, support their mathematical thinking. You know, we've, you know, spent a lot of time trying to think about how to create puzzles that offer kind of easy entry, so ways that students can begin thinking about them, but that are also challenging and offer opportunities for extension. I mean, we spend time thinking about, like, how do we use, like, would an undo button or a reset button in this case support students' thinking? Does it support their engagement with debugging? You know, how should we represent the numbers on the number line if they, for like equivalent fractions or things like that? Even we had in our testing, we offered students the repeat block, and there's some students in our classes that just love the repeat block and build nested repeats, and kind of how do we support their interest in that, but also keep their focus on the mathematics. So, like, for example, we ended up limiting how much they could repeat in some cases. So just really crafting the kinds of environments that would support students' focus on the mathematics and give them still an authentic programming experience. Next slide. So, you know, as you can probably see, students engage with a sort of great variety of kind of important introductory computer science ideas and computational thinking ideas, including building scripts. That's obvious. You know, sometimes they start out with short, simple scripts, but they actually get relatively complex in our later microworlds. Sometimes students are scrolling off the screen. I think these environments, what? Often, yes. These environments, as students are building scripts, they're really, the building and debugging process happen very naturally together. So as they're trying to create scripts to solve the problems, they're kind of working with this notion of debugging, fixing what they see. Because they can see immediately on the stage the impact of their work, they can modify it and see what happens. So there's a really nice way for them in these environments to focus on that and build their skills at debugging. We talked a little bit already about repeat and iteration. I think, and the only other thing I would comment is like how, like in this example, how repeat might support the structure of the number system and support kids' mathematical thinking, so that that programming structure mirrors a mathematical structure. Sequencing, another kind of important, another idea that, you know, comes with building scripts. And, you know, in mathematics, it's interesting because when they first build the scripts for the number line, for example, because of the commutativity, the order doesn't matter so much. But when they get into an environment like the arrays, order really does matter. And so students get experience really thinking about sequencing. Paul mentioned combined steps earlier. The challenges naturally lead into students creating blocks and ideas of abstraction. And then, as you saw in our multiplication microworld, there are opportunities to explore functions and think about inputs and outputs. So those are just very naturally in these environments that are really where our focus is on developing the mathematics. Students, you know, engage with a lot of computational thinking. Next slide. You know, we've been developing and testing these microworlds, and as part of this, we've been engaging in kind of really trying to look closely at students' thinking. We've been working with them in their classrooms. We've been conducting one-on-one cognitive interviews with students, and we really use that to refine those in the environments and drive the changes that we're making in these microworlds. Next slide. We're going to talk just briefly about some of the design principles that we've come to over the years of developing this work. And it just going to start with, we have really kind of honed in on critical math content for the grades, you know, elementary grades, in our case, 2 to 5, in part because that you know, we all know that elementary teachers' time is limited, and we got more buy-in and engagement from teachers where we're really trying to support what they're already doing in their curriculum. So, you know, so working on topics like addition and subtraction, multiplication, fractions that are really central to the mathematics that teachers are already trying to teach. We love using SNAP because it's very accessible and really supports mathematical thinking. And we've really appreciated the partnership with the SNAP team to help us develop these environments. And as you could probably see in the environments, we talked a little bit about this high cognitive demand, low distraction. We're really trying to focus the environments so that students can engage with the mathematics, but have enough opportunity for, you know, challenge. Kate, I think you're going to talk a little bit about a few other.
Yes, I'm going to talk about the final three just briefly. So this notion of experience before formality, I think is so important because it gives students the experience that becomes the foundation for their later formality. They move towards abstraction, and they do that through experimentation and learning from the interaction that they see. And they debug their scripts and they realize what works and what doesn't, which sort of links to the next bullet of the center of locus and control and authority resting in the child, that all of this, like the child is the driver of the work, and that this, the child is the one who decides for themselves whether or not they want to debug a script at that moment or, you know, make a change. And that I think one thing that's an important distinction from in our microworlds is that children see for themselves whether or not that their methods work or not. And then they're the ones that make the change. And the other thing just to mention is that really our microworlds can serve multiple grades with just minor variations. And there's a coherence mathematically to the work. So I'm going to actually move to the next slide. Thank you, Zach. And just to mention very briefly, in terms of our focus on equity, that for our microworlds, that we integrate these microworlds with the core content. June, you spoke to that importance of selecting content that was critical to each grade level so that our microworlds are embedded in the core mathematics instruction. It's not something that happens separate for some students or after school or what have you. This is in the math block that happens during the elementary school day. It broadens, therefore, engagement in programming as well as in the mathematics. And also that, in June, you mentioned this a little bit, that just our problem sets, there's a low threshold and high ceiling, meaning there's access and entry for all. All students can find a way to enter into one of these microworlds. Some students might start at the very beginning, following the puzzles sequentially. We have other friends that like to bop around a little bit and might hop into set 3 and just try out a puzzle, and that's okay, and that's open to them. And then we're supporting access and academic language development for all. We're going to talk about this a little bit later, but our microworlds we have translations built into Spanish, Portuguese. In some microworlds, we have German. We also have audio that can support our developing readers, and that the language that we've chosen for our puzzle sets is really we're trying to make it very clear with minimal text. And finally, the children see themselves as mathematicians and programmers. There's that self-identity piece that's being built here. Next slide. And I'm going to turn it over to Paul, who's going to take us into one of our newest microworlds.
Hi there. So our group is the most wonderful group to work with ever, which means that our discussions often go way over the time we've allocated for them because it's difficult inventing good puzzles. But this happens to have been one of the most challenging. So many Learn to Code courses offer turns and moves, you know, code.org, whatever, but they offer only 90-degree turns and forward moves because the goal is learning to code. And that's right for learning to code, but not for understanding angle. So this world needs more variety of angle, but continuous angle, like you would get in Scratch or Raw Snap, demands a lot of precision. It's hard to see the difference between 90 and 91. And it's hard to draw familiar figures or recognize special angles, also with continuous movement. So we chose, for our world, the variety of 30-degree angles, and that left us lots of problems to solve. Let me switch to showing you the world, if I can. Share the screen, and I want, oh, for heaven's sakes, that one. There. You see the world. Okay. Yes, great. Okay, fine. So with 30-degree angles and the constraint on distance to make sure that you could arrive at a point that you have ever been at before, we decided to mark where the points are. So let me show you a familiar, easy script. Everybody who's touched Scratch or Snap or Logo has done something like this. And the slightly weird result that you get when you do the even more familiar Logo script, repeat 4, move, turn 90. But in this world, distances aren't all the same. So we decided not to talk in terms of distance, but in terms of dots, moves, and you can't talk about negative dots, moving. So we had to create a backup rather than, moving negative dots. But it also means that there are some interesting possibilities, and kids love color. So let me show you one of the possibilities that they can use. Here too, it focuses on angle. So the Snap's fill requires that you be in an area to fill it. That could be a hurdle, a lot of extra, difficulty with moving the right amount and getting in there for kids. But it could also be an opportunity. So in this case, the opportunity is they have to face the area that they're going to fill. Kids do find themselves experimenting, and you'll see this in a moment in a movie. I'm not actually going to say much more about this because the movie itself will be better. So we've had to create, in addition to a reset, we've had to create an undo button. I'd like to go back to one more hurdle that this creates before I show you the movie. So here's that first drawing. And I'm going to turn a little bit and repeat the, did I do it right? Yeah. And repeat this same script. Again, a potential hurdle. The same script shouldn't do a different thing. But in this environment, because we're studying angle, it does. Again, that could be a hurdle. It turned out we were very worried about this, and we weren't sure that we were going to keep it. It turns out that in the classroom, it became an interesting opportunity. One of the teachers said the kids explicitly, noticed that they didn't always get the same size. And one of the teachers thought to ask, so why? And the kids puzzled it out and in another class, the kids themselves came up with that problem. What is going on? What makes that the case? What mathematical thing makes that the case? So is there something that I left out, team? Let's move on to the movie. You'll get a chance to see oh no, actually, let's go on to you exploring this for a moment. It'll only be brief because then you'll see the movie. I will unshare if I can. Where the hell is it? There you are. Okay. Let you get in to explore it. Zach, will you? Everybody has the link here. And take just a little time to explore, because you just want to get the feel yourself, look around at the puzzles, and then you'll see a movie. Okay, so really we should just go to the movie. Who is showing the movie?
Well, I've got the movie.
Okay. I don't really have any comments about the movie. Just watch this beautiful kid. But in particular, try to think about what she's thinking as she's doing the work.
Right. The audio should be shared, but after this title screen goes away, let me know if you don't hear things and we will troubleshoot.
Oh yeah, there it goes. Okay.
And then my turn be this way. 90 degrees. Undo. 90. Then move. Think 2 dots. And a little more. Straight 3.
That looks about right.
Yeah. Then you will
Oh, now this
tilt
is a
it
big turn.
that way. Tilt
So, which way are you turning?
that way. So it's this way. So we'll turn. Let's try 60. Ooh, the other way. It's the wrong one. Let's undo that. 90 degrees. Actually, 120.
Yeah, this looks like a big angle.
Let's try 150. I just wanted so it was like the right. Yeah, that seems about right. Let's move 3 dots.
Can I ask you a couple questions with that?
Oh, that's way too much.
Testing as you're going through.
Big.
What angle?
Can you tell me what your method was there?
I pull a block out and I click it, and that block, once you click it, it will do it on the script.
Yeah.
And if you know that's the correct way to make a shape, you add it on, and you get another block, and you do the same thing, and do the same thing, and then once you attach it, and I found something was wrong right here, but I could have did like walk steps and then like click it, and then it would go and do it and see where it messed up, and then I would stop and click it and see that this turn was messed up and I should add more.
Okay, so here's a place for anybody to comment. Just jump in. I should say that several of the kids, this girl we've been working with since 2nd grade, so she's seen it before. But several of the kids in these classes invented their versions of different ways of debugging. Sometimes this girl used undo a bunch. Some used reset and then reran the project. But there was a lot of thinking. Other comments?
It was interesting that she thought a 90-degree turn would be appropriate at that one point. I think most of us are used to recognizing 90 degrees as a right angle, and clearly a right angle wasn't called for there. So she's developing, I guess, a model of what the different angles do.
Yeah, actually, I found that a little surprising because that's one of the first things that's taught in class, and the kids even model it with their arms, but it's like right angle versus acute and obtuse, and the numeric measure is apparently not stressed. I didn't know that.
And in 4th grade, this was before the students had done their angles unit. I mean, one of the things I think that teachers learned from students interacting was what did students know or not know about angles already from their work, from observing their work in this environment.
one thing that's unusual about this particular student, not unusual, we see a range of kids in terms of how systematic they are. And she's developed a very systematic approach. I think what she's doing when she tries the 90-degree angle is that she's tried 60 and it wasn't enough. And so she's going up stepwise. And maybe not recognizing that 90 would look a certain way. But one of the things you'll see a lot when the kids are working is they're really playing around, because they're used to thinking about it as this, not as I'm headed down and now which way am I turning. And so we saw a lot of kids really trying to think about and doing this sort of thing to figure out, am I making a left turn? Am I making a right turn? Where's the angle? And of course, we all do that as adults too. So we do a lot of it ourselves when we're playing in the Microworld. But we did see kids doing a very, really trying to orient themselves to understanding these angles that were in unusual places that they wouldn't have normally seen in a sort of standard worksheet that they might have done in class. The turns were. It's very visceral to see the kids moving themselves sort of kinesthetically along with the Microworld.
She seemed like she had a very good attitude, like she was very exploratory. She wasn't hard on herself when she made a mistake. Not all students are like that. With the students who are like that, who are self-critical or have math anxiety, have you found your teaching with this has helped?
Yeah, actually, that's an interesting comment. This is a girl who certainly has tenacity and is bright, but also has a pretty, often a very low frustration tolerance. So if things don't go right. So the quick answer is, yeah, kids get engaged because they can, well, it was mentioned earlier, they can check their own work. And so they're not facing somebody or the code itself telling them they're wrong. This is not an app which says, try again. And so they hang in there a little longer. And this girl in particular changed a lot since second grade.
Well, sometimes the teacher is the problem, and maybe I did it in my career, unfortunately. Like maybe at the end of class, they'd say, who finished all the puzzles, right? And
yeah,
then,
it's so natural. It's, yeah.
And then they compare each other. There's always the star student who's always getting perhaps most of the attention.
Yeah, and it's hard not to do that, but here's a place where the kids themselves jump in. I'm sorry, I keep interrupting.
Oh, no, that's okay, Paul. I was going to say we haven't seen a lot of that in our test classrooms. What we have seen is teachers have remarked to us that one of the things they're appreciating is that they're seeing different children become differently engaged in this format in math class than they might in other activities they would do in math class. And sometimes we have heard them say, this is a child who I might usually worry about engagement and they're very engaged. Or I learned something about what this child knew about this topic that I didn't know that they knew because I don't get to see it on a regular basis, but I saw it in this environment. So I think there's something too about the way they can sort of do rapid iterations and try things and try things and try things that leads teachers to be able to see some different things about what kids are thinking as well. So we have generally seen pretty wide engagement across all students. Some obviously need a little support, but we have seen very wide engagement and not always, some of the most engaged kids are not always kids who are as engaged in math content.
Kids also, this is a response to Kobe's question. Kids also work together. Some, I mean, everybody has the opportunity of working independently, and some just sort of focus and don't want to interact. But many will play with each other with these. And in fact, I'm about to show an environment in which that's a part of what they're doing. skip to
Well,
that.
it might be helpful for me to just say that we have been testing in an environment where the kids all do have their own computers in front of them. So it is a one-to-one environment, but the kids sit in groups. And the only sort of paper support we give them is a piece of paper that's a checklist. Some of them use it, some of them don't, that says, you know, I did this puzzle, check. I showed someone, check. And so what the expectation is that they'll show someone, and it could be a teacher in the classroom, it could be one of the researchers that's there. It could also be a friend, a peer, someone sitting next to you. And so it kind of encourages kids to show each other their solutions. And then often what will happen is some kid will be very enthusiastic and something will break out and go viral. And, you know, all of a sudden kids are saying, wait a minute, look, it can do this, it can do that. So
We have only a few more seconds to show. We'll show you a, 10, 20 seconds of a new environment, and then let Zach show you what's underneath it all. Zach, you want to change the? So this is a puzzle, just in English, for kids doing mathematics. It's a bunch of clues to a secret number. The kids love it. Even second graders like making up these things, of course, with simpler clues, clues that they can understand. I'd like to show you a new environment that we have not yet tested with kids, but that we're working on, in which essentially what these clues are attributes of a number. So they're predicates that predicate expressions that the kids would create. So let's take a look at the environment. Next. In this, they can put together a clue, test it to see whether it's true or not, add it to a list, and have that list presented as text, the text you just saw, for their friend to solve. They can put that into a block here, my puzzle, and then give that block to a friend. It will ask the player, the friend, for a number to guess, and it will also give feedback by presenting the same list of clues, but this time as showing it as blocks to the friend, not as this list of English on the stage. It'll show it as a list of blocks with the results, the true, false value of each of those, so that if they don't guess right, they see exactly which clue they've missed. No more to say yet, except we have every good reason to believe, we'll find out whether we're right, we'll have every good reason to believe that kids can do this. And we're eager to try it with our 4th and 5th graders, or at least our 5th graders. Next clue, not clue, Zach.
All right. So one of the things that we wanted to do, in addition to making these worlds, is kind of create a framework that other people could use, either to modify what we've done or to just kind of like do your own thing. So a lot of the things that we needed to do were have a way to like customize the user interface, as you may have seen inside of this direction. Inside of the Microworlds, we have a very limited palette over here. We get rid of the sprite crawl at the bottom. We add some buttons in various places. So if we escape the Microworld, so to do that, just click the snap logo and click escape. This is kind of just our generic base framework. But inside of the Microworld, you're going to see a bunch of scripts that kind of control everything here. So like if we go to the very bottom, you'll see we have all these options to hide various UI elements. You can actually change some of the right-click menus to prevent them from accidentally editing or deleting the built-in blocks, while still allowing them to edit and delete their blocks that they've created. So just all of these modifications that help make sure that they're able to focus on just the things that they need without getting overwhelmed. And at the same time, we can kind of adjust these as they advance. So we might maybe unlock the editing of some blocks as they go farther, or we might in the future introduce the ability to switch between sprites. But everything here is really stored in these hidden sprites that kind of run in the background. So as you could see, like in the number line or in the angles world, there's stuff happening in the background, and that's really just controlled by these sprites that you can't see because that sprite corral is hidden. We've got some annotations. We're hoping to kind of work on the documentation to make this a little bit easier. I'm very excited for some of the new Snap 8 stuff. This big chunk right here is kind of what handles switching between puzzles and sets. And as you can see, we're just doing a lot of parsing of the any message. So I'm very excited for those messages that can contain their own data, because that's going to make this a lot more readable and not this huge, scary script. We've also added translations, text-to-speech, and audio recordings to help make the puzzles more accessible. So that was a bit of a challenge, just thinking about how we could translate things. For some of the worlds, we need to, like the map world, we need to be able to insert the custom names into those translations, and then have that be able to be read out loud. So I don't know if we showed this in Microworlds, but when you click on the puzzler,
drag out blocks and click on them,
it will read the puzzle to you. And we've got support for both human recordings, as well as you saw here, just this robot text to speech. And there's just a whole mechanism for it to check if it's the right, if it's got a recording, it'll play that. If not, it'll default to text to speech. It also checks the language that you're set in to make sure it's translated. So lots of things happening back there. And so we were really thinking about, originally this started as kind of a fork of Snap. And then last year when they introduced the extensions, pretty much all of this now is done through the extension. It's just really modifying some of that internal Snap behavior that then turns itself off when you escape out of the micro world. And we've really been kind of keeping an eye on things that are changing in Snap. And over time, we've been able to take stuff out of the extension, because now it's just supported natively. I'm excited to kind of make some of those Snap 8 changes to this, and I think it'll be really cool. So with that, we'll jump back to here because we are almost out of time. These are a few examples of places where this work has been implemented by others. So last year at SnapCon, we met a person named Desmond D'Souza, who is working with students in schools in India to develop a series of computational thinking in, I think, grades K to 12. So the microworlds are just one part of this bigger program that he's starting to build up, which is awesome. We also heard from someone who teaches digital literacy in Germany, and she actually helped us translate some of these microworlds into German. And one of the nice things in the microworlds is, even if you go up to the top here, it's actually fairly straightforward for people to just place their own translations into here, which we'll have documentation for eventually. And then a few other examples. This is actually a project that I did with third graders, kind of built on a Scratch project where you're supposed to only use 10 different kinds of blocks or so to tell a story. So again, we limited which blocks were available. And then an organization, I believe in Spain, called City Lab has kind of worked to use this microworld framework to create their own completely new sets of puzzles. So this one here has to do with shapes and kind of translations and stuff like that. Here's a video. We're not going to watch it now, but if you want to see kind of an overview of this project, if you click this link, it'll take you to this STEM for All video. I'm going to skip through the student reactions. You should have the slides, so you're welcome to go back and read through these. And finally, we have a website right here that has some of these microworlds at the moment. It's going to have all of them, hopefully sooner than later, as well as just news and developments about this. And finally, we have a handout that has all of our contact information on it, as well as links to all of the worlds that we showed you in the beginning. So if you want to play around with those or try to customize them, you are welcome to do that. And with that, I think we have like 30 seconds for questions.
But certainly contact us if 30 seconds is inadequate.
This is very cool. I'm going to study the code and learn a lot.
Awesome.
Glad you're, please build new micro worlds.
The escape microworld concept, is that your own creation, or is that a Snap thing?
Zach built that.
I think Bernat had it originally. So Bernat Romagosa is one of the Snap developers who kind of laid a lot of the base work for the previous version of this. And then the new version with the extensions is just a lot of his code and then some modifications on top of that. but he had came up with that easy way to get in and out.
And the code is mostly written in Snap itself. There's some JavaScript, I guess.
Yeah, we tried to make it so that like a Microworld developer, like if you're making your own, you shouldn't need to touch the JavaScript, hopefully. We're still making a few tweaks there. But the things that allow the changes, like getting rid of UI elements, are written in JavaScript that are then exposed to Snap through those extensions. So yes and no.
I see.
Yeah. Yeah, presumably a new developer of a Microworld. So I do a lot of the Microworld itself building. So this Bangles Microworld or something. Presumably that person doesn't have to deal with the JavaScript at all and is building it strictly in Snap. And Zach has been working very hard to make that really easy for people to build new Microworlds.
At the beginning, when you had the +3 and the -3, do you talk about negative numbers at that point, if it's elementary school?
Great question. We don't, because we would be thrown out of school if we asked an elementary, a second grader, anything about negative numbers. So we don't ask them to go there. We don't ask them to use that facility. But not only do they all land there by accident, many go there on purpose, and everybody, every single one of them, when they land on something like -3, recognize it, probably from siblings, and they all know how to get back, and furthermore know what the result will be. So you land on -3 and you click 3, you're on 0, you click 5, you're on 2, and it's as if that's the beginning. They just do it, but we can't ask it.
We don't ask it, but we do deliberately place 0 not all the way to the left of the number line.
Yeah.
Right, I noticed that.
Yeah.
We make it discoverable.
Possible and discussable, yes.
Yeah.
And it feels very natural to the kids, you know, because it's a natural extension of the thinking they're already doing.
Yeah. That's another design principle that we actually didn't write about, which is make new stuff discoverable without forcing the teacher to deal with it. Again, the same principle. The teacher might well understand it all, but it's not part of their curriculum, and they can't be, you know, present in 22 places all at once.
I'm asking a lot of questions about internals, but and I apologize. How did you draw the arcs on the number line project? And if that's too technical,
no, it's the old logo. How do you make a circle?
Oh, it's actually a polygon, part of a polygon then?
Yeah.
With sides of very small length. I see. Thank you.
We're at time. I just want to thank everyone for coming. You know, feel free to reach out to us if you have questions, and we'll stay around for a little while if there's anyone who has questions now as well. But thank you for coming.
Yeah, thank you so much.